Okay, so let's see this particular question. What do you understand by amphoteric oxide? And give the balanced equation for the reaction with three different amphoteric oxides. We will see uh, three different amphoteric oxides with a caustic alkali. Okay, okay, with a caustic alkali. Okay, so now first we will see what is this amphoteric oxide. Okay, first it is, so amphoteric oxides, amphoteric oxides are those oxides which show what, acidic as well as basic character. So basically amphoteric oxides, amphoteric oxides are amphoteric oxides are those oxide which show which show which show acidic as well as basic character, just I'm giving you one information. Oxides are what, of three types mainly. Oxides are what, whether they are, maybe they are what, acidic, maybe they are what, acidic, or maybe they're what, basic. Generally your non-metal oxides are what, acidic in nature. Generally your non-metal oxides are what, non-metal oxides are what non-metal oxides are what, acidic in nature. Okay, basic, your metal oxides are what, basic in nature. your metal oxides your metal oxides are what, basic in nature. One more type, that is what, your amphoteric oxide. Okay, amphoteric oxides. So these oxides what, these oxides show both property, that is your, they are what, acidic as well as they are what, basic in nature. Okay, so they react with acid, as well as they react with what, base. Like suppose I'm taking about this example, that is your ZNO. So look at this, why this is amphoteric oxide, because it reacts with acid also. Suppose this is ZNO plus HCl. So in this case ZnCl2 will form, and plus your water will form. Okay, so it is reacting with this acid, that is your hydrochloric acid, HCl, aqueous, better to write. Okay, and second case, this particular ZNO is reacting with what, your NaOH also. Okay, this is reacting with what, NaOH, and it is forming what, Na2 ZNO2 and plus what, H2O. So look at this particular oxide, the same oxide is reacting with what, HCl as well as base. So that's why these oxides are what, here if it is reacting as acid, that means what, it is acting as what, a basic oxide you can say. And if it is reacting with base, it is acting as what, acidic oxide. So that's why we call this oxide what, amphoteric oxide. And there are one more type of oxides that you will study. Okay, and that is your what, neutral oxide. Neutral oxide, very important, very important. You have to remember this neutral oxide. Only 4 neutral oxides are there in chemistry, that you have to remember. Okay, so that is what you, how only 4 neutral oxides, that is what is CO, that is your carbon monoxide. Then it is what, N2O, nitrous oxide. Then it is what, NO, nitric oxide. And H2O, this is the oxide of your hydrogen. So these 4 oxides are what, your neutral oxides. Okay, so now come to again, this amphoteric oxides are what, those oxides which show acidic as well as what, basic character. So we define this amphoteric oxide, and with the help of ZNO we show what is the meaning of, I hope you guys understand this particular concept. Okay, that what is the meaning of this amphoteric oxide. Now see, give the balanced equation for the reaction with 3 different amphoteric oxides. So balanced equation for the reaction with 3 different amphoteric oxide with a caustic alkali. Okay, caustic alkali, so maybe it is NaOH, or maybe it is what, your KOH. Okay, so we have 3 amphoteric oxides. This is what, is ZNO, then it is what, your Al2O3, and then it is what, your lead oxide, that is your PbO, that is what is PbO. Okay, and this is ZNO, suppose reacting with this NaO. We already talk about NaOH, so let's here take as KOH. Okay, so let's take what, KOH. Here take NaOH, and here take again what, NaOH. Okay, and this is what will form basically what here. So it is what, 2 KOH, it will form what, K2 and Zn, K2 ZnO2, and plus what, plus H2O. Okay, this is what your potassium zincate. 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 And as they are saying in the question, write your observation if any. So the observation will be what? They are colorless and soluble. They are what? Potassium zincate is what your colorless and soluble. Okay, colorless and soluble. Now look at this one. This is what your NaOH plus Al2O3. So basically it will form what? NaAl O2, NaAlO2. Okay, and this is what your 2, because, and this is what your, because aluminum has 2. Okay, so and plus what, your H2O, plus what, your H2O. Now it is balanced or not, first see that this is what your L2O3. Al is balanced. Okay, now sodium is balanced, perfect. What about oxygen? 2 oxygen here, 3, 2, 3, 5. 2 into 2, 2 into 2 is 4, plus 1 5, and hydrogen is what, 2. Okay, perfect, it's balanced. Okay, and what about this NaOAlO2? So this is what your sodium aluminate. This is what your sodium aluminate, and this one is your what, your white. Okay, this one is your white. Okay, so this is the reaction. And the last one is, it is what your, when your PbO, that is your PbO is what, your yellow. PbO is your yellow. This one is your white. This one is your white. And this is again ZNO is what, again white. Okay, and these are what, the part of solution. Okay, these are the part of solution, colorless solution. Okay, and this will form what, when a PbO will react with this NaOH, it will form what, Na2 PbO2, Na2 PbO2. And this one is what, plus water, of course, is plus water. So look at this, you have to put here 2. And what is the name of this? Again, sodium plumbate. Sodium plumbate. Okay, sodium plumbate. And this one is again what, colorless and soluble. This one is again what, colorless and what, soluble. This one is again colorless and soluble. Okay, so we took what, 3 different amphoteric oxides, and we reacted with what, these what, caustic alkali. Okay, in case you can here use KOH also. What you have to do, just replace this Na with what, K, or you can use KOH also. Here what you have to do, just replace this Na with what, K. Got the point? Hope you understand this particular concept. Okay.